So starting by looking at the key words that are involved in your project. Your project involves something called a PIC chip. That's a peripheral interface controller, something which is going to look at inputs and then control what the outputs do as a result, based on the way that you've programmed it. It is a very simple version of computer control at a very base level. It's nowhere near as complex as what you find inside of your computers, your laptops, not even as complex as inside of your smartphone, but a very simple version. It has inputs connected to it, it has outputs connected to it, and depending on how you program it, then that computer chip will control the outputs depending on the inputs. System block diagram. This is a simple schematic which shows each of the stages within your main system. It's done as literally commands written inside of boxes with arrows going between them, and it literally says, I want this to happen as my input, I want this to happen in the process, and then I want this to happen in the output. It doesn't go into any detail of how it's going to achieve it. It just literally says, here is an overview of the entire system. Within your system block diagram, you've got several system blocks. As I said before, they can be inputs, they can be processed, they can be output, and they can be combined together in numerous different ways. When you've moved on from your system block diagram, you may then start working on a flow chart. Now your flow chart is what you're going to have to write to control your PIC chip in your little buggy. You're going to have to set it up so that you produce a series of commands that you can download to it, and it will literally, when you turn it on, it will run through all the commands in your flow chart. It's made up of terminators, decision boxes, output boxes, and process boxes. A schematic is a simplified diagram. The schematic is a simplified diagram. One of the most commonly known schematics is the map of the London Underground, where you've got your interchange stations shown as circles, and you've got the stations in between are just shown sort of equidistance in between. You know, the likelihood that Chancery Lane is actually that distance from Holborn, is actually that distance from St Paul's, is actually that distance to the bank, is small. So Covent Garden's a perfect example. They've just put it slap bang in the middle. It's clear to read, but it's not accurate to the layout on the ground. So a schematic is a simplified version of a diagram. An input is any switch or sensor which is going to take data from the outside, whether it's heat, light, sound, movement, and convert it into an electronic signal. Process is when you are manipulating the electronic signal within a circuit, so it could be time delays, it could be logic gates, it could be transducers, it could be the actual PIC chip. And an output is where you convert that electronic signal into a different energy. You would transfer the energy, so it could go to sound, movement, light, heat, etc. When you're looking at these charts, you're looking at what's referred to as logic high and logic low. Logic high is when you have a voltage and it's represented with a 1. Logic low is when you don't have a voltage and it's represented as a 0. A terminator box in a flowchart is literally the start and stop boxes within a flowchart. A wait box, exactly what it says. You would put in wait, and then you put the period of time you wanted to wait for, so it could be waiting for 500 milliseconds, it could be waiting for 15 seconds, but while it's in that box it will just literally wait before it moves on to the next section. A decision box, which is the shape of a diamond, is used for your inputs, and you're literally asking the question, is the input logic high or logic low? The other way of writing it is a switch turned on, in which case it would be logic high, or is it turned off, in which case it would be logic low. And your decision box always has a yes and a no feedback arrow coming out of it, so that if the answer to the question is the input high, it'll do one thing, and if the answer is it's not high, then it'll do the other. PIC chip, peripheral interface controller, literally the brains of your circuit, the thing that is going to be looking at what's happening with your inputs to decide what to do with your outputs. But it can't work unless you've written a flowchart or a program for it to function, because it has to follow the commands in the flowchart. A motor driver, this is often a chip which literally can be used to turn a motor on, cause the motor to turn clockwise or anti-clockwise, and give sufficient voltage and current to ensure the motor can turn. And finally, a printed circuit board. This is a mask for a printed circuit board. This is a real-world version of your printed circuit board, and it's the board that we've made for you to put the components on for your project to work.